Hello, good afternoon, everyone. This is Lisa Youngers, the President and CEO of the Fiber Broadband Association, and welcome to today's webinar. We are thrilled about today's webinar because we are going to hear from Mike Hines, Chairman of the Fiber Optic Sensing Association, or FOSA, and he's going to give us an overview of FOSA as an organization and Fiber Broadband Affiliate, its structure and mission, and provide a few examples of how FOSA generates material and completes its work, some of its advocacy and education and priorities. A little bit about Mike Hines. As I said, he's chairman of FOSA. He's also a market manager for industrial sensing with OFS in Avon, Connecticut. Mike is responsible for market, product, and business development and industrial sensing for applications in upstream, midstream, and downstream oil and gas markets, including downhole pipeline and reservoir monitoring. Mike is also actively involved with technologies to help bring value to the rail and perimeter security markets through distributed fiber optic sensing. Mike has a background in marketing and economics and is a 25-year veteran of the fiber optics industry with a focus on specifically optical fiber and associated technologies. Mike holds a Bachelor of Science degree in marketing and a master's in business administration. And with that, I'm very happy to turn this over to Mike Hines. Thank you so much, Mike, for leading us through this important webinar.
Yeah, thank you very much, Lisa, and thank you to the Fiber Broadband Association for the invitation to present on behalf of the Fiber Optic Sensing Association, or FOSA. As Lisa mentioned, I'm Mike Hines. I work for OFS, and for 2018, I'm serving as the chairman of FOSA. As many of you know already, FOSA is an affiliate of the FBA, and today we're here really to explain a bit about what FOSA is, the work that we do, technologies that we support, and provide a few examples of the work that we're doing to give you all a better sense for what FOSA is and what we're about. So let's get started. So in the presentation, basically I'll go through the structure of FOSA, the members of FOSA, what our markets are, and what the output of our efforts is, and then provide a couple more detailed kind of deep dive examples of the projects that we're working on. So just as a reminder, FOSA is a relatively new organization. We started in May of 2017, based in Washington, D.C. Our charter is really to promote distributed fiber optic sensing across many of the markets that can benefit from the technology. And how are we doing that? Well, basically, we're providing education around the various forms of distributed fiber optic sensing. We've got some technology awareness campaigns that we're working on. We have a fairly active effort in public policy around DFOS, and then generally promoting DFOS solutions through other trade associations when we have opportunities to speak at them and so forth. Membership is open to companies globally. We do focus right now on the North American market, but we aspire to grow beyond North America in the coming years. So you can expect to see activities in Europe, Latin America, Asia, and so forth. And the organization is very hands-on. So we've got working committees that you'll see as I put up a slide on structure that get very involved in producing the documentation and so forth that we use to communicate to the broader market. So if we look at the next slide, we have 19 members today, and we're hoping to have at least 30 by this time next year. So we've got fairly aggressive growth plans. But you'll see in the list of members, we've got a smattering of fiber optic interrogator producers, and these are the companies that make the active equipment that gets attached to the fiber optic sensing cables, and they do the data gathering and interpretation and analytics. We have a number of companies that are involved with installations such as Ditch Witch, and also Duraline, which is a conduit supplier that I think everybody in the FBA is familiar with. And then we have other groups that are involved more in the way of integration. And then finally, we have a number of cable companies that are producing either telecoms grade cable products or specialty sensing cables, depending on the application at hand. So that gives you a sense for who's involved with FOSA today. If we look at the structure for FOSA, we're very much member-driven. We do have a board of directors. The way the board is organized, we have 11 members on the board. 2 of those members are FBA permanent slots, so we have guidance from the FBA. And the remaining 9 basically change out 2-year terms on a rotating basis. So, 4 expire in 1 year, and then 5 expire the following year, and we go through an election process to keep the board full. For the FOSA management team, we've got a chairman, vice chair, secretary, and treasurer, and then we've got the expert help of Mark Unkefer as our director and Joy Maloney as our e-media director. So they've been tremendously helpful in getting the FOSA organization up and running. Now, when it comes to the actual work product, FOSA basically has 4 committees set up targeting specific areas. So one is the technology committee. And as you can imagine, the technology committee is busy working on describing the various forms of distributed fiber optic sensing and their applications. So they're putting lots of primers together and presentations, and sometimes going out on the speaking circuit. We have the FOSA Public Policy Committee. That's a committee very active in the work around legislation and regulation with respect to distributed fiber optic sensing. So that's a very helpful crew, and they've made some great progress that we'll talk about in the upcoming slides. Then we have the FOSA Economic Justification Committee, and this kind of harks back to how the Fiber to the Home Council first started. When it first began some 15 years ago, one of the first issues was to try to explain to the market the economic cost-benefit analysis of a fiber to the home system. So if we fast forward to 2018 and look at distributed fiber optic sensing, we have a similar challenge. So many industries can take advantage of this technology, but they don't yet understand the economics, the investment, and the payback associated with such systems. So we're busy putting mathematical models together to help explain those benefits to the industries that we're targeting. And then finally, we have the FOSA Market Development Committee, and this group is very active in seeking out trade events, speaking engagements for FOSA and the like. And they're also putting together a calendar of events that we keep up to date on the FOSA website. So I encourage you all to go to the FOSA website, fiberopticsensing.org, and check out what we have there at your leisure. So what is it that we produce? So all the committees that I just mentioned work together, and they produce basically documents and webinars. And this is primarily focused on educating markets around these emerging technologies called distributed fiber optic sensing. So we have a website chock full of information. We have freely downloadable technology primers that break down the various DFOS methods in a very simple, high-level language. We've begun to develop installation consideration documents. These are not installation guidelines, but more importantly, they're intended for the audience that's considering the use of DFOS in an application, and they may need to try to understand what needs to be considered when planning an installation. So they're fairly high level, but also very helpful. Lots of case studies on the FOSA website, and then we also hold a monthly webinar series, and we record those webinars and put them onto our YouTube channel. So I encourage anybody with interest to seek out the Fiber Optic Sensing Association YouTube channel and check out some of the webinars. They're actually really interesting and really helpful. So what is DFOS, distributed fiber optic sensing? Basically, it's using optical fiber, usually in a cable format, to detect either temperature or acoustics or strain. Basically what happens is you would run a cable. It may simply be a telecom cable that's in place already, or you run a special cable along an asset, for example, a pipeline, and you can detect things. In the image above, you'll see that the optical interrogator is placed sort of mid-span, and then you would have cables running, to either side of it out to about 40 or 50 kilometers, and you can detect things like foot traffic or vehicular traffic. You can detect leaks. You can detect all sorts of acoustic vibrational events and then pinpoint them along that asset. So if you have a pipeline that you're trying to monitor and you're concerned about leaking, well, in using fiber optic sensing, you can identify the leak within minutes, and you can pinpoint to within about 5 or 10 meters where the leak's actually occurring. So this is a huge value to the pipeline operators who are trying to improve the safety of the pipelines that they operate throughout the world. This next slide depicts how the actual systems work. In all cases, you're starting with a laser pulse from the interrogator, and you're simply sending pulses along a fiber or cable. And there's naturally occurring backscatter that happens within the glass structure itself. And as that backscatter gets sent back toward the interrogator, it gets peeled out and analyzed. In the event that there's an occurrence along the length of that sensor, if it's a vibrational occurrence, or it could be a temperature occurrence or a strain occurrence, what happens is the signal back at the interrogator gets flagged, and then you can send a crew out to try to mitigate any problems or investigate the problems, and you pinpoint the locations. It's pretty handy technology. And as I mentioned before, you can use typically standard telecom grade cables, but there are a fair number of specialty cables put together to do things like improve the sensitivity or improve the signal to noise ratio of the sensors themselves. So if we look at markets, again, applying DTS, distributed temperature sensing, DAS, distributed acoustic or vibration sensing, and DSS, distributed strain sensing, we can provide benefit in pipeline condition monitoring, pipeline heat trace monitoring. If you have product like crude oil that needs to be heated along its pathway to flow, you want to make sure that the heating is consistent. So heat trace monitoring is intended to do that. Intrusion and security features of DAS help you identify threats, perhaps on a perimeter or along a railroad. Geotechnics, you can do quite a bit with distributed fiber optic sensing, specifically strain sensing, to detect movement within the earth itself that may threaten an installation of some sort. Transportation monitoring, upstream, in-well oil and gas monitoring, industrial process controls, structural health monitoring, power, and then the emerging market is really smart cities and highways. If you think about deploying this technology along highways or within cities, there's quite a bit that you can do to detect and provide useful information to the municipalities that are surrounding these assets. So go to the next slide. What are the specific applications? I'll just touch on a few here because there are quite a few of them. But if we look at the methods, DAS, DTS, and DSS, and compare them to the markets, you'll see in the fine print on the slide quite a few different things that you can do from an application standpoint. So if we take DTS versus pipeline condition monitoring in the midstream, you can detect leaks, you can detect soil erosion, trace heating and power monitoring. If you look at DSS in geotechnics, you can find landslides in dams and dikes, earth movement, that sort of thing. In oil and gas upstream, if you're using DAS, you can do vertical seismic profiling, understand the fracking process, and then with temperature, you can understand the temperature profile of the entire well, and that tells the operator quite a bit about the health of the well, where to apply changes in the operation of the well, and how to basically produce more productively and more safely. So that's just a few examples. The list kind of goes on, but you can read this at your leisure. The next slide is really the first example of some of the work that we're doing. We've referred to pipelines quite a few times in the presentation, and I'll give you a little bit more background on that. In the U.S. alone, there are about 2.6 million miles of pipeline. Most are buried. And if we look at the way that regulation works in the United States, basically the governance of pipelines falls under the U.S. Department of Transportation. So there's a group called the Pipeline Hazardous Materials Safety Administration, or PHMSA for short. They're responsible for safety along pipelines, and they're a peer organization to groups that like the Federal Aviation Administration, the Federal Railroad Administration, Federal Highway Administration, and so forth. So FOSA is a relatively new regulator, and if you look at the table on this slide, you'll notice that there are quite a few supporting laboratories. Some are owned publicly, some are public-private ventures, but they're intended to help these regulators assess new technologies and apply them to the various areas of responsibility. So the FAA, for example, has the William J. Hughes Technology Center to look at new aerospace technologies. FRA has the Transportation Technology Center and the like. As it turns out, there's a bit of a gap in the pipeline area, and there's no sort of central pipeline safety test facility. So we've recognized the gap and we've begun to study it. Went out and did some surveys with customers and pipeline operators, technology experts, and have come up with some concepts that we'll get into in the next slide, basically to help propose a way to fill this gap, how to fill that red circle in with a United States-based pipeline safety test facility. So this next slide is really the result. It's a concept drawing based upon inputs from the survey that FOSA conducted with the pipeline operators and various technology suppliers. And you'll see on the graphic itself, it's basically a flow loop that's intended to be buried. It's intended to pass through numerous types of soils with various engineered leaks, basically orifices, to simulate liquid or gas leaks along a pipeline. And so you can picture around this facility, which is probably a mile or two in circumference. You can picture sensing cables that are buried alongside, probably in conduit, some direct buried, and then interrogators that can be swapped in and out to do basically assessments or validation on the technologies themselves. So we think that there's an interesting need for this. We've published our work, and we've met with quite a few different organizations, trade associations, the regulators themselves, and legislators, really to vet the idea for the concept. The next step for us really is to organize funds for a thorough architectural and engineering study of such a site. This would be intended to predict the cost to build and operate, perhaps where to locate it, and then how to fund it, probably through some sort of public-private partnership. And then following that, if that's successful, it would be moving on to ways to actually fund the construction of such a site and put it into operation. So that's one example of a project that we're working on. The proposal is gaining interest. 88% of those that we surveyed indicated that they would use the facility. So these are primarily pipeline operators that would be interested in validating technology and performing R&D with such a site. The regulator, FOSA, is also open to the idea. We've had a few meetings with them and attended some of their R&D events, and they seem to be quite enthusiastic about it. And then the Senate Commerce Committee that basically authorizes the money to keep FOSA going is considering this in support of it for its reauthorization of FOSA in 2019. So lots going on from a public policy and technology committee standpoint to get this project done, but provides a good example for the audience around this project. The next example, I think, is maybe a bit more directly related to what happens within the Fiber Broadband Association. So we're hearing a lot in the market today about smart cities, and I think there are quite a few different technologies from the sensing world that will eventually find themselves included as part of the smart city. So the slide right now depicts kind of what's being used in the telecom space around smart cities. And if you start to lay over on those same cables, same telecom cables, things like distributed temperature sensing, distributed acoustic sensing, strain sensing, and such, you'll start to see there are things that can be learned through the sensing, right? So you can monitor traffic, for example, and you can pinpoint where log jams or bottlenecks are occurring along highways. You can look at things like strain effects on the rail system. You can detect things like flat wheels on trains, determine where rails are beginning to break and potentially cause derailments. and just generally improve the information that cities have around the transportation infrastructure. So lots can be done if you can detect strain, temperature, and acoustics, and then changes can be made to the highway system, essentially to make them more intelligent. And I think that's ultimately the goal that smart cities has, right? How do you monitor the conditions in highways and rails and so forth, so that you can route traffic the most efficient way possible. So that's the idea behind the use of distributed fiber optic sensing for smart cities. It's an emerging area for us, so we're still solving many of the problems. But what we know today is that there's strong interest from municipalities and cities around the use of smarter sensing, and we expect a very, very positive future combining sensing with telecommunications in smart city applications of the future. So that brings us around to really a sort of a wrap-up slide. Just to kind of summarize, distributed fiber optic sensing is an incredibly capable technology. It does solve problems when deployed correctly, and we're learning almost on a daily basis of new things that it can solve as the R&D continues in this space. We're starting to shift the interesting findings into practical application across many markets. And it's unique because it detects things like strain, temperature, vibration, acoustics in a distributed way. And this is a point that I probably didn't make too clearly early in the presentation. By using a pulsed laser along these sensing cables, you're basically turning the entire cable into a series of sensors with very, very high spatial resolution. You can kind of program it, but you can get down to about 1 meter per sensing element or sensing point. So if you have a 50,000 meter long sensing cable, you can create 50,000 microphones, for example, in the acoustic domain. So it's really, really interesting technology, and I think it's definitely going to continue to solve lots of problems worldwide. If we look at the DFOS market, we've gathered some data from within the FOSA membership, keeping in mind that FOSA does not have all the DFOS players as its members yet, but we've got a good cross-section. We estimate that about 60,000 miles of distributed fiber optic sensing is installed across the world today. And then market study estimates range from anywhere from 800 million to 1.2 billion in revenue potential in 2018, rising up to as much as 3.6 billion in just a few short years. So high growth market, lots of problems to solve, and we're very bullish on the future of distributed fiber optic sensing. So getting back to FOSA, we were created primarily to provide education, to start to bring the merits of this technology out to as many markets as we can, in the hopes of growing these markets for the benefit of the FOSA members. I touched on the various markets. There are quite a few of them, but I think one of the more important ones will be smart cities. And I think there's a nice crossover between that and what the FBA member companies are involved with already. So you may see sensing beginning to move into the sort of the FBA space in a very synergistic way. So I know that that's happening. I think that's about all I have for today. Hopefully it gives you a flavor for what FOSA is about and what types of technologies we support, and then maybe how we're going about establishing and building markets for the technology. So with that, I'll open the floor to any questions that you might have. So
okay, thank you, Mike. Oh, do you see the questions? Good.
Yeah, I can see a question. So on the topic of smart cities, can you talk about the emergence of the marketplace for smart city applications? Who will be the buyers and sellers of those services? So this is a great question, and the way I'll couch it is this. We've heard from a number of cities and sort of smart structure companies. The interest level around distributed fiber optic sensing is very high, but like the FTTH market of 15 years ago, the value proposition and the cost benefit analysis and business models need to be developed to answer specific market requirements. So you'll probably find in the coming years some very specific value props that are coming out around sensing to answer just these questions. So, the municipalities are asking, what data can we get? How much does that cost? How can we use it? And then out of that come, things like new business models that help to essentially collect the data, analyze the data, and provide it to municipalities in forms that they can act on. So hopefully that helps to clarify, where we are in the market and what we expect to occur in the future. Are there any other questions on the line at the moment? I don't see any. There is one question that came across that says, talk about when one is better off using existing cable versus using new sensing cable. So, kind of a broad topic, but in general, distributed temperature sensing, distributed strain sensing, and distributed acoustic sensing, the interrogators that do the detection for these various sensing methods can be connected to existing cables. So if you have a telecom cable that's buried in the ground or in conduit along some sort of infrastructure, there's a strong likelihood that it can be used in its current state to make some level of detection. And of course, the placement of that cable in relation to what it's trying to monitor, pipeline, for example, or maybe a railroad or a highway, has an impact on the efficiency of the sensing. So installation is critically important. Sometimes you can use what's already in the ground. And also note that there are quite a few technologies being developed to simplify the installation process and enable you to detect events essentially more easily with less worry about the installation method. So there's a lot of technology that's being developed around solving future problems of DAS, some of which will be telecom-related cables, and some of which will be special types of fibers and cables, perhaps embedded in telecom cables. So lots going on there. Okay, so let's see here. So we have a question here. I'm a fiber optic instructor and wish to add a chapter of fiber optic sensing. If you have material, would you care to share it? Would be appreciated. Yeah, so the answer to that question is we have a fair amount of material, and you can either contact me directly through FOSA, or you can actually just check out fiberopticsensing.org, and under the tab called Resources, you'll find a fair number of technology primers and installation consideration documents, and then lots of case studies that'll help you to develop your coursework. And then also on top of that, you might want to look into the FOSA YouTube channel, because there we have lots of very, very detailed webinar videos that you can look at and learn quite a bit about the sensing aspects. So hopefully that helps answer your question. Okay, are there any other questions? I'm coursing through the list here. Yeah, it looks like that was the final question. Lisa, Carol, do you see anything else that I'm missing?
There's one last question on here about where this webinar will be posted. I will post it on the Fiber Broadband Association website under events/webinars, and I will also pass the recording over to FOSA. So one way or another, you can view or download the presentation if you need it.
Great. Well, thank you for doing that. Okay. Well, I think we've answered the questions that have come in. I hope the webinar today was useful for the audience, and I encourage you to contact the Fiber Optic Sensing Association with any further questions that you might have. And for companies out there that are looking to get engaged or involved with fiber sensing, please consider joining FOSA as a member. I think you'll find that it's a very, very good group, very actively involved in the marketplace, and it's a place that's ripe for learning, and we could also use your contributions. So thank you very much, and have a great day.
Thank you very much, Mike. It was very informative. We really appreciate it. Thanks, everybody, for joining.
Thanks, Lisa.